Mr. Biffi, yeah, we can start with your presentation, please.
Okay, thank you. Good morning, everyone. Almost afternoon. Apologies for the disruption, and I hope you can hear me well and good. For several decades, the deployment and use of self-contained self-rescuers has been an integral part of the emergency escape and rescue procedures from areas affected by irrespirable atmospheres. When done, self-rescuers, as opposed to gas masks or respirators, form an isolated breathing circuit that allows you to breathe stored or chemically generated oxygen mixed with exhaled air after scrubbing the exhaled carbon dioxide. The self-rescue is intended to separate hermetically the respiratory system of escaping persons from the toxic environment, enabling them to reach a place of safety, such as surface or a place of refuge where respirable air will be readily available. By its design and size, the self-rescuer is a sophisticated, compact, and robust safety device that forms part of the daily life of miners and that therefore requires an understanding of its operation and capability once activated. The life-saving function of self-rescuers must be complemented by effective, carefully laid out and well-maintained escape routes, well-managed and executable rescue procedures, and efficient auxiliary supporting infrastructure that may include the positioning of refuge bays, fresh air bases, self-contained self-rescue caches, and changeover station within the radius of operation provided by the oxygen generated by the unit in use. To attain consistently the full life-sustaining capacity afforded by self-rescuers, workers must be proficient in the use of these units and be familiar with emergency evacuation procedures. This paper details the training requirements studied from the 1980s and developed over several years, and that incorporate lessons learned through tragic loss of life, empirical methodologies developed to ensure that miners can respond adequately when forced to don self-rescuers in emergencies. In the United States, the development has given rise to what is termed experiential training, which has been extended also to the use of refuge bays and the managing of underground emergency procedures by supervisors. The most insightful realization is that in a stressful situation, mine workers' response to any emergency is similar to that of humans that find themselves in a hostile and stressful environment. I don't know if you can see my pointer, but this is what you usually see when you travel by air. That's the visual instruction given and also shown by the air hostess on how to place a gas mask over your mouth. This is the intended outcome, and usually this is what happens. As you can see, the instructions are not really followed to the letter, and this can cause these passengers to die or suffer injury because they're not wearing the mask as intended. A generic insight into these situations was done by Drager in 2016 and indicated that, firstly, miners respond promptly to alarms, so long as it is evident that there is an obviously immediate danger threatening their life. Once they discover that the alarm is real, miners are not likely to panic. Miners understand that unscheduled incidents in industrial environments are possible, Panic may ensue, however, once the perception of a great danger for oneself or others, the belief that rescue is possible, but escape routes are limited and or are restricted, and that a feeling of helplessness in avoiding the impending danger is realized. In an emergency, miners are likely to assist each other in reaching safety thanks to the inborn social perception that there is strength in numbers in addressing both physical and psychological challenges. These three reactions have been observed in several rescue situations. More importantly, they are valuable in developing awareness and training programs that will provide the necessary preparation for emergency response and self-rescue. Stressful conditions may be mitigated to some extent by the knowledge that additional safety measures such as escape route alternatives and refuge bays, adequate safety equipment such as early detection of gases and warning devices, good communication to surface and self-rescuers, all backed up by regular and adequate training, are at the miner's disposal. Soon after the introduction of self-rescuers in the early 1980s, Coal Mining Authority in the United States came to the realization that the life-saving potential of self-rescuers would be fully realized only once correct donning procedures were followed during emergencies. In the 1990s, the United States Bureau of Mines divided a computer-based simulation that would determine the probability of miners making a successful escape while wearing self-rescuers based on specific observation. This work was based on the assumption that the probability for a successful escape was based on meeting three factors. Firstly, adequate miner training in the donning of the self-contained self-rescuers. Optimal working conditions of the self-rescuer when this was activated. And thirdly, that the self-contained self-rescue would provide enough oxygen to match the miner's demand while negotiating the escape route. The findings in terms of the workers' training would use the selection of one of 5 levels of worker proficiency observed in the donning of the self-rescuers based on the standardized sequence. The proficiency levels were 4: failing, poor, marginal, or adequate. And in the 5th one would be perfect. In terms of self-contained self-rescue integrity, the units were deemed either to be in good condition or not functional at all as a result of manufacturing defects or damage from the working environment. In the United States Mining Bureau of Mines, estimates of worker oxygen consumption was based on the length of the escape route, mass of the worker, and 3 postures: walking, upright, or bent or crawling. The most significant finding is that the variance and the relative odds for survival from the test was as high as 30%, and this difference was deemed to be attributable to the ability to don self-contained self-rescue alone, as indicated in this graph, where you have a comparison of the proficiency of 4 mines, and these are the various ranges of proficiency. You can see quite clearly that the percentages vary from mine to mine, and that the conclusion given for this is that the donning efficiency is responsible for 30% of the variance. So it's important that the donning efficiency is at the right level to ensure the safety of workers. In the studies done in the United States between 1985 and 93, the same research team provided further insight into self-contained self-rescue training requirements based on a number of incidents. And the research indicated that the industry was undergoing a learning curve similar to that experienced by early emergency and rescue response teams that were issued with self-breathing apparatus in the early 1920s. Following from several incidents in those early years, intensive training of these selected men was introduced to improve their skills in doing rescue work in difficult circumstances when using self-breathing apparatus. When self-rescues were introduced for use by all coal miners in the United States, the situation was somewhat different, however. Where brigadesmen in mine rescue teams were and are well-trained, fit, and motivated individuals who make use of their self-breathing apparatus while rescuing fellow miners. Normal miners seldom get to operate or see a self-contained self-rescue in action. This slide that you see now is it gives an indication of the kind of training that self-rescue team training was introduced to back in the 1920s. And it would involve well-trained volunteers, motivated individuals who were prepared to face up to conditions that they would encounter. They would be provided with 20-hour initial instruction over 5 days, and then 9 practical hours in the donning of the breathing apparatus. And then there would be additional instruction and practice at 6 monthly intervals. So this is an example of how intense the training was then, and is probably even more so today in modern times. I'm sure that, Rian earlier spoke about the men assessment of breathing apparatus. This is in South Africa. It's a training laboratory that is being developed by Mine Rescue Services, and that is used by rescue team members to also to assess the capacity and approval of self-contained self-rescue. This is part of their training. In further research work that was performed just before the turn of the century, based on interviews of 46 miners involved in escaped experiences, several findings were made based on these testimonies, and these have relevance in defining the basis of expectations training. A significant observation from these include the fact that miners felt nervous about the hazardous condition to which they were exposed during the incident, and some admitted to panicking. Some miners admitted that they did not know what to do when the emergency occurred. None of the miners had worn a self-contained self-rescue prior to the time at which the emergency occurred. In general, miners indicated that they were not proficient in donning self-rescues and had trouble locating the oxygen activation system where this was provided. In an emergency that requires activation, go back. All right, so the conclusion from this research program indicated that miners do not respond immediately to the requirement for donning self-contained self-rescues when smoke is detected, if they perceive that they may extend the life of the self-contained self-rescues. and impending danger may not seem to be dire. Hands-on training would assist miners while experiencing the donning procedure, including the correct insertion of the mouthpiece, breathing from the device to experience the increase in breathing resistance and high inhalation temperature, self-pacing during the escape to reduce stress and consequently oxygen demand, the use of underground self-contained self-rescue caches, locating these along escape routes and practicing self-contained self-rescue changeover at cache stations. Effective means should be provided to warn miners of all crews timely and clearly of impending dangerous conditions through communication from a control room and or by providing gas monitoring devices that would be monitoring carbon monoxide and oxygen. Poor visibility adds to the stress levels and anxiety of workers affected by the emergency. Periodic and frequent hands-on retraining and evaluation based on initial training methodology should take place. In all cases, training is to be monitored by competent and knowledgeable trainers who can provide immediate feedback and correct less than adequate conditions and behavior. The occurrence of 2 gas explosions and a fire in the United States during 2006, and which resulted in the death of 19 miners, made regulating authorities aware, amongst others, of the need to improve the training of coal miners in the correct use of self-contained self-rescues and in creating greater awareness of escape procedures to ensure their safety. Within months, the United States Department of Labor published emergency temporary standards that required miners working underground to be able to find life-saving devices rapidly and to use them to evacuate the mine quickly. In addition, these standards recognize that the lack of training in deploying supplemental self-contained self-rescuers in irrespirable atmospheres and the lack of lifelines in coal mine escapeways presented a grave danger when a fire, explosion, or other mine emergency occurred. The conclusion was that traditional show and tell training, similar to the ones we saw earlier on the aeroplane, was not suitable for this application because, according to psychologists on their research teams, donning and activating self-contained self-rescuers requires the mastery of a fairly complicated motor task that must be performed accurately, often in very stressful and dire circumstances. In addition, the use of oxygen breather apparatus, by its nature, requires a certain degree of familiarity with its operating principles and mechanisms. So what is expectation training? Expectation training is a set of procedures specifically developed to provide sufficient physical, cognitive, psychological, and behavioral information beyond the necessary technical information and hands-on experience that will allow trainees to experience any physical and psychological conditions to which they might be exposed while performing a task or action. Expectations training affords trainees the opportunity to experience abnormal conditions and to develop appropriate responses. The use of simulations during miner training stimulates trainees to seek information actively and make own judgments about.
Okay, I will take over from what Marco ended. He was actually explaining as to what an expectation training is. And it is a set of procedures specifically developed to provide sufficient physical, cognitive, psychological, and behavioral information that will allow trainees to experience any physical and psychological conditions which they might be exposed to while performing a task. And it goes further to say an expectation training affords trainees the opportunity to experience abnormal conditions and to develop appropriate response. Then we also have simulations that are used during expectation training. And this is mainly to prepare the users in case of emergency. And what the two writers are saying is that if one is taught how to use the rescue pack, that person stands a better chance of survival in case of emergency. And if you are just showing and telling them, then it becomes a challenge. Then the next writer shows that if you spoon feed me, then you are basically teaching me nothing. The expectation training program requires exposure to both physical and psychological stressors, so that you are aware of the situation as it happens. What do we mean when we talk about the physical stressors? We talk about activating the self-rescue packs, and of course, different mines use different types of rescue packs. So activating different types of rescue packs in a conditions where there is poor visibility, and we also look at the time that an individual reacts to don the units or to activate the unit. Again, we talk about the external and internal heat. Majority of us know that the self-contained self-rescue pack, the reaction that takes place is exothermic, meaning that there is heat which is produced during the chemical reaction. So one needs to be aware of the heat that comes from the rescue pack. Quality of breathed air, hot and dry or hot and humid. And of course, during breathing from the self-contained self-rescue pack, you'd experience some unfamiliar taste. There's also some irritations from the upper respiratory tract, and this might also result in coughing. There is also what we call resistance to breathing. Obviously, when one is evacuating a dangerous area, the way one walks has an impact on how one breathes. Therefore, one has to do the self-pacing so that you can build up the confidence from what the units can give out. A rescue pack, it's not complete if we don't have the breathing bag. So we need to be aware that it may also be an hindrance when one is evacuating the toxic area. So we should be able to accommodate the condition of the bag. And of course, for one to isolate himself or herself from the irrespirable atmosphere, you need to have the nose clips correctly mounted on the nose so that you do not inhale toxic gases. We have seen in other rescue packs that are equipped with goggles. Unfortunately, it's not the case for all the approved rescue packs in South Africa. But for those rescue packs that are equipped with the goggles, the users needs to be taught or trained on how to put on the goggles to avoid itching of eyes. Then there's also what we call psychological stressors, and manage survival instincts during the traumatic event. Control potential negative effects of instinctive reaction. Then there's also physical consequences when one is using the rescue pack. There's dry mouth, there's sweaty palms, and there's a lot of sweating, and the heartbeat changes because of the condition that one is in, and that might result in one breathing or shallow breathing, meaning that not sufficient breathing, and you may also experience nausea. There's increased anxiety, and one feels overwhelmed, you become disorientated, and most of the time you become also confused. One needs to also be aware of the breathing rate. The higher you breathe, the shorter it will take for your unit to takes you to the place of safety. And the more you breathe slow, there is higher chance of survival or reaching the place of safety. And we all know that in case of emergency, we are always advised to hawk steadily. In an emergency situation, we need to remain together as colleagues so that if one experiences some challenges, we are able to assist and look out for each other. There's also some guidance or assistance in terms of evacuating in poor visibility conditions, the use of lifelines or other directional guidance devices. And one needs to focus on the escape to increase the survival chance. One should not remove the mouthpiece during an emergency escape. And as part of training, people or miners are advised or trained to remove the rescue packs once they've reached a refuge base or refuge chambers. That's where they can get fresh air. And then in terms of training in South Africa, the requirements are included in the SANS 1737, as it was mentioned by Marco and the fellow colleague, Rian. And this is mandatory. It's compulsory for the mine operators to follow these requirements. And what the standard says is that there should be a use of training sets. The miners should be trained on how to don the units. And there should be a simulation of heat and breathing resistance. There should be some reference cuts. Each miner or each self-contained self-rescue user has to have a reference cut where he can make some reference in terms of what needs to be done in case of emergency. There's also the use of posters and audio visuals. Normally, the posters hang up on the halls on the way to underground. And in training purpose, training centers, they use visuals, videos to train the rescue pack users. And then we've got here a picture on the left-hand side below. There is a picture of a rescue pack, a training unit, and the trainer there is showing, it's meant to show the users on how to don the units and also showing them the components that are included in a rescue pack. And then in the middle column, we've got a reference card. The reference card would include all the steps that are used when doing a rescue pack, from the very first step until the last one. We've got a heat simulator on the right-hand side, and this is commonly used by the mine operators. And you can see that there are breathing tubes hanged on this simulator. Then there is some disposable mouthpieces. So you'll have a number of people standing around this simulator just to experience the inhalation temperature when a rescue pack is done. And what we have done also in South Africa is that we have conducted a research, basically looking at the women in mining. We have seen a number of women joining the mining industry in an effort to assess how well do they don the unit, how well do they put the rescue packs on their body. This study was conducted. And out of that study, the average time that it took to don the unit was 2.5 minutes. And according to the manufacturers, this is a long time. Within 60 seconds, the user of the self-contained self-rescuers should be able to don a unit within a minute. There's also what we call COMRO guideline. This document is used to guide the mine operators in terms of placing the refuge chambers or the place of safety underground, doing the calculations in terms of different areas. And it also shows the guideline in terms of how the body posture look like in different areas underground. And that's what we have here. And this is basically an extract from the COMRO guideline. And South African industry at the moment, they are looking at revising this document because there is technological changes in terms of the rescue packs that we have. But we have also went further in terms of the country, in terms of training. We've got what we call the experiential training unit. This is what you see here, the middle picture. It's what we call the experiential training that will be used by our mines. And on the right-hand side, it's a pictogram of how it looks like when it's done. There's some additional goggles which the user will be able to use. And what is required in terms of preparing the users or the miners so that they are aware of the expectation training? Expose tough miners to cognitive and psychological aspects of escape. We talked about psychological and physiological stressors in the previous slides. Development and adaptation of expectation training for South African workforce. Obviously, certain things needs to be adapted to accommodate this training. Acceptance by the mine operators. The burden here is placed on the mine operators. Obviously, they will be spending resources in terms of equipping their mines or making them ready to conduct this training, and also making their workforce available. So they need to accept that this needs to happen. And in terms of the underground workforce population in South Africa, we're looking at more than quarter of a million. That's 250,000 workers. and they need to be trained annually. And there's also regular training which is done on 6 monthly basis. And this, as I said earlier, needs to be accepted by the mine operators. So there's additional 1.5 million man hours per annum that is required in terms of making the expectation training successful. There should be some infrastructure to support the initiative and the resources. Obviously, one needs trained personnel in terms of making sure that the effort or the initiative is a success. Well, there's always challenges, and the real challenge for the embedded South African mining industry will be the efforts and resources needed to implement the expectation training proved to be successful. And that brings us to the conclusion. However, we've got some points that leads to this conclusion. The deployment of self-contained self-rescues in underground mines is aimed at ensuring the survival of workers in the event of sudden development of irrespirable atmosphere. Obviously, emergencies are not planned. So this effort to have the expectation training, it's mainly to achieve that purpose so that the workers survive in case of emergency. In South Africa, what we have seen through the monitoring program that Rian shared earlier is that self-contained self-rescue technology is mature. It's mature, and it's an important component of a much more complex and extensive mine-wide emergency evacuation strategy. And self-rescue packs are not simple devices. They are sophisticated items of equipment, and donning them requires mastery of art. Evidence from underground fire incidents in South African mining industry has shown that fires still occur, and that the severity of some of these incidents requires the activation of mine emergency procedures. Although there is training which does happen to the miners or the emergency rescue teams, but there are still gaps that needs to be closed. Analysis of rescue operation indicates that although largely successful, the extensive deployment of self-contained self-rescues requires a step improvement in the quality of training to avoid fatalities. Expectation training is deemed to be evolutionary in combining technical hands-on coaching together with psychological preparation of workers to face infrequent but potentially disastrous and therefore traumatic events. Adequate and effective preparation is necessary to ensure the requisite physical, cognitive, and psychological response from all workers required to use self-contained self-rescues during emergency evacuation. We did mention that one needs to be aware of what is expected from the rescue pack once it's deployed. Self-contained self-rescue expectation training for South African mines requires careful and planned adaptation of such procedure to accommodate local conditions and the South African workforce. I spoke about COMRO guideline. These COMRO guidelines cannot be used in any other mines, but it's specifically developed for South African mining conditions. There might be other standard procedures or steps that are contained in that document. But if, say, somebody in Australia wants to use that document, obviously that mine operator needs to adapt or customize the COMRO guide to fit the conditions that are in a specific mine. Planning for and procurement of the extensive resources and time allocation necessary for expectation training must be considered carefully. We spoke about acceptance by the mine operators. Obviously, they will need to invest some resources in making the expectation training a success. And that brings me to the end of the presentation, and I hope Marco is back on the line so that we can assist each other to answer the questions. But my colleague is also available here in terms of answering the questions that might arise. Thank you.
Коллеги, да, спасибо за...
Okay, thank you so much for your presentation. We have some questions, so let me voice them out. The first question, what efficient practices of guiding, of instructing workers do you use when you perform training? So what sort of like guiding procedures do you use?
In terms of training, the training is conducted by the self-contained manufacturers, and they do intensive training in terms of how to don the unit, how to react to a condition that requires one to don the unit, but also there are some other mines or some other manufacturers who already have the training unit, which is used during the training to make sure that the users are able to don the unit from step 1 until the last step. And I also mentioned about the video that it's used at the mines when they conduct training. But also the COMRO guideline provides the steps as to what one needs to do in terms of successfully escaping a toxic environment. Did I answer the question sufficiently?
Yeah, we have another question. So to what extent are your trainings close to real life conditions, considering the behavior, considering the physical conditions that the workers may encounter in case of emergency? Yeah, because, for example, chemically bonded oxygen can be perceived in different way by different people. Yeah, so in terms of these physical conditions, to what extent are your trainings close to real life?
Look, it's unfortunately impractical to simulate the real life emergencies. But however, the mine operators, they have, or some of the mine operators, they have what we call the mock mines, where they conduct training to ensure that at least the miners are aware of the emergencies that they might face underground. And in those mock mines, they try by all means to simulate the close to a real emergency, where they can do poor visibility and use the rescue packs, the actual rescue packs, which are nearing their end of life. And that assist in terms of the miners to experience the physical and psychological stresses that we spoke about. And the fact that these training are conducted regularly, that helps in terms of preparing the self-contained self-rescue users how to react in case of emergency. Are there more questions?
Есть еще.
Yes, thank you. We have a couple of more questions. Yeah, maybe there is a comment. Okay, Rian, probably, yeah.
Thank you, colleagues. Now, I just wanted to also expand on what Michael was answering in terms of the extent to which training of mine workers represents the actual conditions. As Michael said, at some mines, there are mock mine setup, representation of the underground environment, and this can be used effectively for a variety of training purposes, including training in the use of self-rescue and escape strategies. However, this is not something that is necessarily the same across our whole mining industry. And so from our side, we are encouraging that, that lifelike and experiential training is used. And the CSIR is currently also developing such a training offering from our side. It is not operational yet, but in the near future, the CSIR will also be offering training, especially in emergency response procedures, including the deployment and the use of self-contained self-rescuers, and those first few minutes that the worker need to proceed from the place of work to a place of safety. As we realize that this is something that would add tremendous value to the emergency response training if a realistic representation and experiential training
Есть еще у нас ряд вопросов.
Okay, thank you. We have some more questions. So when you perform trainings, do you use the real self-rescuers, or are there some simulations of these rescuers? And do you use this, fume, smoke, or something, yeah, to hamper the vision?
The use of the real self-contained self-rescue pack, it's an expensive exercise, and I did mention that in other mines where they have rescue packs which are approaching their service life, their end of service life, they use those rescue packs. But apart from that, the use of what we call the training unit, which is not a real rescue pack, it's used. And at the mines, yes, they do introduce, or they change the condition of the mock mines where they do have mock mines to introduce or to create poor visibility. just to assess if the miners or underground miners will be able to evacuate a condition where the visibility it's insufficient. The use of real rescue packs or the actual self-contained self-rescue, it's not common because these are expensive devices.
Еще у нас есть вопрос.
Okay, thanks. And another question. So, do you perform trainings in real mines, like trainings for knowledge of escape exits? For example, do you perform such training so that the workers know where the escape exits are? And how often do you perform such trainings if you perform them?
Yeah, maybe I should have at least in advance just let the fellow colleagues on this platform know that I work for the CSIR, where we do the self-contained self-rescue annual monitoring program. However, I do have some insights in terms of how the training is done in the mines. There are cases where training is done underground, mainly to equip the miners with the knowledge in terms of how to evacuate the toxic environment to the refuge bay. And this is mainly done to also assess in terms of the effectiveness of evacuating the working phase to the refuge chambers, monitoring the time that the miners take to get to those place of safety. And we must also remember that we spoke about COMRO guideline, and that document guides the mine operators as to what needs to happen in terms of their risk assessment and the mitigations in terms of the risks. So obviously, if one puts the document that assists the miners to evacuate from a toxic environment to place of safety, you need to have done the practicals in terms of calculating the time that it will take from a working phase to the refuge chamber or place of safety. So yes, the practical is done also underground to make sure that in the risk assessment or in the escape procedures, they include factual information that came from the real training that took place underground. Unfortunately, the underground is very difficult to simulate poor visibility. So it's a challenge. In terms of the frequency, we've got a guideline that supports the regulation that it's used in terms of the annual monitoring program, or that supports the guideline for the use of rescue packs in underground situations. In that document, there is an emphasis in terms of how regular the training needs to happen. So it may be, well, it starts from monthly, 3 monthly, 6 monthly, and annually. So it will depend on the mine operator as to how often they want to do the regular training.